Okay, so today we'll be working on how to graph inequalities or how to solve inequalities. So they're very similar to equations. There's slightly some differences in inequalities versus equations, and we'll talk about that as we go. All right, so in order for us to do the um, graphing of inequalities, we have to understand what inequalities really are. So we've got the less thans, we got the greater thans, we got the greater than or equal to's, and the less than or equal to's. And the way, again, that you read it is always from left to right. So if you see the smaller end of the inequality listed first, it's less than. If you see the bigger end as you read from left to right, then that's greater than, and that's how that works. So you're going to use a closed dot or closed circle, if you want to call it that, for anything that's greater than or equal to or less than or equal to. And you're going to use an open dot for anything that's greater than or less than. So if you don't, basically the rule of thumb is close it if you say equal to. Keep it open if you don't when you read the inequality symbol. All right, so the first thing we're going to do is graph several of these just to see what it looks like. All right, so first thing we're going to do is it says x is less than 3. And less than 3, so we're going to, here's the 3 right here. So we're going to put, because I didn't say equal to, I'm going to put an open dot on the 3. And what that really means is you can start around 3, but you don't want to be on the actual 3. And then I need all the numbers that are smaller. Again, this is less than, smaller than 3, which would be 2, 1, 0, and so on. So it would be all of these. So we're going to make a graph that goes in this direction forever. So this is saying I can pick all of these numbers, all of them, all the way up to 3, but not including 3. So I can pick. The reason why you have an open dot here is because you can go all the way up to 3, but not include 3. Because remember that this number line, even though you're seeing 0, 2, 4, 6, or 0, 1, 2, 3, 4, 5, 6, and so on, there's infinite number of numbers between 1 and 2, or 0 and 1. There's all those decimals. So technically, I can go all the way up to 3, meaning I can pick 2.99999999999 and so on. That's technically less than 3. So I can go all the way up to 3, but I can't include 3. So I can walk all the way up to 3, but I can't actually step on the number 3. So I can approach it as much as I can. That's what they, in mathematics, that's what we say. We can approach that number, but we can't actually get on it. All right, so now we have number 2, greater than. So we're going to pick -1, which is right here, -1. We're going to do an open dot again because I didn't say equal to. In fact, I probably should put it on the number, but I'm showing it above so you can actually see it. And then I need numbers that are bigger than that, so I'm going to go this way. Again, I can pick anything above -1. So if I picked -0.999999999, that's bigger than -1. So again, the open dot allows me to walk all the way up to -1, but not actually step on -1. Okay, x is greater than or equal to 7. So here's 7. I'm going to put a closed dot on there because I get to include 7 because I say equal to, so I can include 7 and all the numbers to the right, 8, 9, 10, so on. Okay, next one, -5. Negatives sometimes get a little bit, it's difficult for students, but remember that less is going off to the left-hand side, greater than is going to the right side. All right. Now that you know how to write them on the graph, can you go from the graph back to the inequality? That's a good question. All right, so again, I see that -2 is my key number. So I'm going to put a -2 down. I have to decide, am I doing less than or I'm doing greater than? Okay, so I am doing less than. And since this is open, I'm not equal to. And then I'll just put my variable. So x is less than -2. Okay, number 6. Put my x. I know all my numbers are greater than. I know I have a 4. And because my dot's filled in, I'm going to say equal to. Okay. X less than goes in the other direction. Dot is filled in. Equal to. And then 0 is the number I'm on. Okay, last one. Okay, I put an X down. I find my, okay, I'm going to the right, which is greater than. My dot is open, so I'm not going to put equal to, and it's bigger than, looks like -3. All right. Okay, so now that you've gotten the idea of how to graph it, one of the things you have to be able to do, actually, the things that you're going to have to be able to do is you're going to apply your lesson of 1 and 2 step equations, solving them, and then you're going to apply it to solving inequalities, and when you get done, you're going to graph your answer on the number line. So you're going to have graphs that look like this. Okay? All right, so there's only one rule that you have to remember in solving inequalities, and that is you must flip the inequality sign whenever you multiply or divide by a negative number. Okay, now what I mean by that is you're dividing by, and the key word here is by. It doesn't mean that there was already a negative there and I'm dividing. It means the number that I divided by each side of my equation is a negative. So in this first one, since there's not a negative number on the x, when I go to divide, I'm not going to flip this symbol. Here, there's no negative attached to this x, so I'm not going to flip the inequality symbol. And then we've got some on the back that we're going to look at. All right, so just kind of reviewing basically how to solve equations. I'll do this kind of fast because you can go and look at our lesson on equations, solving equations, in order to look back on how to do this. So I'm going to do these fairly quickly. All right, so I'm going to subtract. Remember that we're doing PEMDAS in reverse. So we're doing any adding or subtracting first, and then any multiplying or dividing second. Okay, so again, if you're undoing, remember the trick is you're undoing the equation. All right, so I'm going to subtract 2 on both sides. I have a, now, and again, I would put that little vertical line in there until you get used to it, and then put a 3x because these are gone. I got my symbol. And then I have -4 minus 2, which is -6. Okay? Divide by 3. See how I divided by a positive number? So this rule up here does not apply. I didn't divide by a negative. I divided by a positive. So x is less than -2. Even though I have a negative in my problem, I did not divide by a negative. So I'm going to leave it alone. All right, so since your number lines are blank, what I would suggest you do is just put -2 kind of in the middle, and then write numbers on either side. Now, sometimes it's a little difficult with negative numbers because our brains have a hard time with the negatives go that way to the left. So -1 is over here and -3 is on the other side. And sometimes that hurts our brain a little bit. Whoops, this would be a 4. So just be careful. That's all. All right, so I read this again. I have an open dot on the -2, and it's less than, so I'm going there. Remember, less is going to the left, and greater than is going to the right. Numbers are getting bigger this way, and they're going less going that way. All right, next one. Okay, so I subtract 2 from both sides again because I have add 2, so I'm subtracting 2. I get x divided by 6, bring down the symbol, and then this is -3. Check that with Desmos if you need to, or your calculator on your phone to make sure you're getting this number right. Okay, and I have divide by 6, so I'm going to multiply by 6. And again, since I multiplied by a positive number, this does not apply. Okay, so I have x is greater than -18. Again, put the -18 in the middle. Put some negatives on either side so I know where you are. I have an open dot on the -18, and I'm going to the right because right is greater than. Greater than's to the right, less than's to the left. All right, so then we're going to do a couple of these problems just to kind of practice. I'm just going to do a couple of these because pretty much you've been practicing the one-step and two-step equations already, so I just want to do a couple of problems where that negative comes into play, and then I should be done. All right, so number 11, let's do that one. Okay, number 11, I'm going to subtract 8 from both sides. I have negative 7x is less than or equal to, looks like negative 7. Again, now when I go to divide, notice I'm dividing by a negative. When I'm dividing by a negative, okay, now my symbol is going to change direction. Okay, so only when I divide by. So see how here I was dividing by a positive number, so my symbol stayed the same. Okay, so that trick is the dividing by. I divide by a negative. That means literally what's happened is the variable has changed from a negative to a positive. That's really, see how this is negative 7, now it's a positive. Negative 7x, now it's a positive x. So basically when the variable changes sign, that's when your symbol has to change. All right, and then again I put a 1 over here, 2, 3, 0, negative 1, negative 2. All right, and then I'm doing 1, have a solid dot because I say equal to, and numbers are greater than going to the right. And that's what it looks like. Okay. All right, so let's jump down on some of these little harder ones. Let's see. I think let's do number 16 because those are complicated. So I'm going to do something like that one, and then we'll do 20, and then that should be it for the notes. All right, so number 16, you're going to add 1 to both sides. Now I have negative 5/6 x is greater than or equal to, looks like 15. All right, now I got to get rid of this. Let me clean this up a little bit. You would think my numbers would be neater being a math teacher, but they just aren't. All right, I got to get rid of negative 5/6. So if you recall, in order to do that, we have to multiply by the reciprocal, or then these flipped over. Again, if you forget, all you have to remember is to knock each other out. They have to be at kind of diagonal for each other. So you put a 6 here and a 5 there. And again, put a negative. It doesn't matter whether it's on the 5 or the 6. It doesn't matter because it's a negative. As long as a negative and negative make it positive, you're good to go. So I'm going to write that over here. Okay, so now I get x. Now remember, you multiplied by a negative, so this symbol has to change direction. And then when I do this math, I can put this in the calculator. Let's see, this is going to give me, it looks like negative 18. All right, put a negative 18 down. This is a negative 17. This is a negative 19. Throw a bunch of numbers down here. Please make sure that when you're doing your classwork, you fill out the entire number line. I'm just trying to keep the videos as short as I can. All right, so again, negative 18, fill in the dot because of the equal to. And then it's less than, so less than goes to the left, greater than goes to the right. So less is left. Okay. And that's it. Now the last one I wanted to cover was number 20 because of the fact that you've got this special one. I talked about it in the last lesson. What do I do when I have this instance? Well, in this instance, I can't do adding or subtracting first because these guys up here are locked into a division problem. So in this particular case, I have to do a multiplication, get rid of this division first before I can take out this 11. All right. So if you ever see this instance where everything is above a number, you got to get rid of the number first. All right. So I'm going to write this down here just so we have some room. Okay, so I have to multiply by negative 2 on both sides. So now that knocks the negative 2 out with this, and I get x plus 11. Now, because I multiply by a negative, this symbol has to change direction. And then this is 4, because negative 2 times negative 2 is 4. And then I subtract. I don't have a lot of room here, but I'll get x is greater than -7. Be careful. Don't forget that's the only thing you have to remember is that symbol has to flip whenever you multiply or divide by a negative. Okay, so again, remember how this is technically this whole thing, the variable is a negative, and you now made it a positive, so the symbol has to change direction. All right, so I put -7 down, -6, -5, -8, -9. I put a open dot because I'm not saying equal to when I read this, and then I'm going to go to the right because greater than is to the right, less than is to the left. And that's it for today.